is Ogechi. All man supposed to know.
Now moving on to RIP. Let's do a health check on this router. So on router 1, I just loaded configuration for my RIP lesson. And on router 1, this is how we configure RIP protocol, routing information protocol. Let's check it out. Show protocols. So when you're in global config mode, Juniper, you can check show commands directly. Show protocols, RIP, display in set commands, enter. This is all I did on the Juniper router. I just said set protocols. I would like to set RIP protocol. I'm creating a group called RIP, a named group, and I'm gonna have my neighbor on these interfaces. That's it. That's the only configuration. That's a simple configuration. That's all I need to do, because it's a dynamic protocol. I don't have to tell it, oh, advertise this or that route. I mean, okay, we'll get to that later on, but basically it's a simple configuration. You just tell it create RIP configuration and point RIP to these interfaces. So from this interface and that interface, that's pretty much it, right? Now I have an export policy that tells it what to advertise. So by default on Juniper routers, for RIP, before you can advertise a route, right, you'd have to put a policy to tell it what to advertise, basically. But it can accept routes though. But for advertisement, you have to tell it what to advertise. So let's take a look at what I put for the advertisement policy. Show policy options, policy statement. You write a manual statement policy, and that statement was, I called it static to dynamic, displayed in set commands, enter. So basically I created a policy that says create this policy. I would like to match anything from these routes, then accept. If I put this in, let me put this in a different format so you can read it this way. So basically this is the same policy option I created. It's called static dynamic, and it says term 1. So it's like a if then else statement basically. So term 1 is the first statement. It says allow anything from this routes, right? These are direct routes. Accept them. Anything else rejects. So I'm only matching these specific direct routes, and I'm matching that, and I'm now exporting that into the policy. So the policy is calling what I want to advertise through RIP, and I'm saying you can now export these out to outside of RIP basically. So that's the configuration on router 1. Router 2 has a similar configuration. Let's check it out. Show routing, show protocols, RIP, displayed in set, enter. Now for router 2, I also have RIP configuration pointing to its two interfaces, this interface and that interface. Then I have an export policy telling it what to export out, because remember, for RIP to export configuration, for it to tell another router, you have to tell it, okay, you have to export that information into RIP, right? It's not going to just automatically advertise, its networks basically. So I have an export statement saying export this policy. So this policy I'm exporting is me manually telling it I want you to tell other routers about these routes. Now I can check it out like I did before. Show policy options, policy statement called RIP, display set, and now this is the statement that I created. I said export anything that's learned from RIP out to everybody else. That's the statement that's matching on router 2. Now on router 3, I gotta put a RIP configuration on router 3, and it's pretty simple. It's a Cisco device. So go to global configuration mode. I say go into router RIP configuration, router RIP. Then I would say I want to make it RIP version 2, and I'll put a network statement. So now on router 3, I'm trying to enable RIP on these interfaces, but I want to use a network statement to match. It's going to look for any IP address that has any interface that has a matching IP address. Is going to enable RIP on that interface. So I want to say match configure RIP on any interface that has a 10.network, enter. Then my second network statement, because I want to advertise my 172 addresses also, So these addresses I want to advertise as well. They're all 172, right? So I can put another network statement that says network 172.16.3.0. I want to match that. Or I can say 172.16.0.0. I want to match this network, and I say enter. That's all you need to do on RIP. Now I'm just going to look for every interface it has, and if they have an IP address that falls within this network or that network, it's going to enable RIP in it. Now let's see if this worked. On router 3, let's check the routing table. That's all I needed to do, right? Show IP route on router 3, and let's see what happens. This is the routing table of router 3. You can see all the connected routes, right, that it knows about. You see this R over here? R means RIP. There's a table, a key table that tells you what symbols mean. So you can see R means RIP, right? So basically this router 3 has learned these RIP routes and done this look familiar. These are the routes that were advertised from router 1. So router 1 told router 2, hey, I know about these routes. Router 2 now sends those routes to router 3, and router 3 dynamically learned those routes. And you can see this number here, 120, is the administrative distance, the admin distance of RIP. Remember on the we talked about that earlier where we talked about admin distance and route preference, right? So RIP has an admin distance of 120. Now this other number is talking about the metric. We talked about metric also, right? Like the distance to reaching a route. Cool. So we see that router 3 has knowledge of router 1's routes. Let's go to router 2 and see how router 2 got that knowledge. Oh, also let me show you how Cisco order information on RIP on Cisco device. So if I do show IP RIP, database, it shows us the RIP database. It just shows us like what it's seeing. It shows that it has auto summary turned on. It did an auto summary for the 172.16 network. Okay, cool. Now let's go to router 2 and see how router 2 learned about the routes from router 1, and let's see how router 2 learns about the routes from router 3 as well. So we're on router 2 and we do show run show route protocol RIP. So you can see the differences between Juniper and Cisco, right? They're doing the same thing, but they just have different commands. Run show route protocol RIP. I want to see the routes learned from RIP protocol. Click enter. These are the routes that router 2 has learned from RIP protocol. You can see it has learned about, it's weird, it learned about the 172.16 addresses advertised by router 3. It also learned about the specific /32 networks as well, and it got summarized because of it's summarized between the major network, basically, because you had the 172 address and it's a major network, and you had a 10 address on the link to router 2. So basically router 2 knows about how to get to these addresses advertised by router 3. Router 2 also knows how to get to router 1's addresses. If you scroll down, you see it's learning that through RIP as well. These are router 1's addresses. So that's pretty awesome. That's pretty awesome right there. Yep, that's pretty awesome. And yep, you can see its admin distance for Juniper for RIP is 100, and you can see that there. And you can see its metric. Its metric is 2 hops for this network. So router 2 is saying the metric to 192.168.1.1 as 2 hops. So 1 hop to this interface and another hop to the loopback, basically. Router 2 also says its distance to addresses from router 3 as 2 hops as well, metric of 2, basically. So router 2 has that information. Now let's go to router 1 to see what it has. On router 1, we can do the same. Let's check the routing table, show route protocol RIP. And you can see router 1 has learned about the 172 addresses. Router 2 learned it and sent it to router 1, and they're all there. Now its hop count is 3. Basically, router 1 is saying 1 hop to get to router 2, another hop to get to router 3, and another hop to get to the loopback address on router 3 basically. So it's 3 hops for it. It's pretty cool, right? Cool. And when we go to router 3, we can see similar thing. We can see the routing table on router 3, show IP route RIP. Router 3 has learned about these addresses from router 1, all in the routing table. And that's pretty cool. So it was dynamically told. But now the problem with RIP is that it sends updates every 30 seconds, right? If I turn on debug for RIP, we should be able to see the updates as they come in every 30 seconds. And you can see what I'm saying right now. You can see updates coming every 30 seconds, telling the router about the same route that has been learned. See, it's telling the router about these routes, and it's coming every 30 seconds, basically. And that's the chatty nature of RIP. It's gonna keep on router 3. We're gonna keep on seeing these updates coming in from router 2, and you know, telling him about all the routes in the routing table every 30 seconds, basically. So chatty. Cool. Now let's test reachability from router 3. Let's see if we can ping router 1's loopback. Let's see that right now. Drum roll. I'm gonna ping the 192 address, sourcing from my 172 address, and it's successful again. So we've used a RIP protocol to ping router 1. Basically, router 3 can ping router 1 using RIP, and it's successful. And we can go all the way to router 1 to check the same thing. Run ping. We're pinging 172.16.3.3. We're sourcing that from 192.168.1.1, 1.11. Let's see. Oh no, should be on router 1. Let's go to router 1. Also wrong router. On router 1, and it's working. On the Juniper router, I'm pinging the Cisco router's addresses, and I'm sourcing from my loopback, and it's also successful. So RIP also works, and it's pretty cool. But you saw the inefficiencies in RIP, right? You saw in router 2 where it was receiving updates when I turned on debug on router 3. You saw all this debug where router 2 was sending updates every 30 seconds. That's very inefficient and very chatty, right? Cool. And now for RIP, in Cisco, the RIP doesn't really form a neighbor adjacency with the other router. So there's no show IP RIP neighbor. It doesn't exist in Cisco. You're just learning routes from neighbors basically, because RIP is routing by rumor. So it's like I heard router 1 tells router 2 about a route, and router 2 tells that gossip to router 3. So RIP is just popularly called routing by rumor because it hears routes from rumors basically. But how believable are those, right? You know how rumors are, right? You can tell somebody something, tell 10 people the same thing, and by the 10th person, the same information is skewed, right? Because there's gonna be some people adding more information to whatever you told the person. So basically, RIP is just routing by rumor, routing by what was heard from the neighbor, right? So there really isn't a neighbor relationship between router 3 and router 2. But Juniper, on the other hand, is quite different. So if I did on router 1, if I did show RIP neighbor, it shows you that on these ports, the local state is up, and it tells you that it's sending the traffic, the updates as multicast, right, to this address, basically. You can see that. So it shows you a state, basically, on Juniper.